Climate Science Part 4, Wikipedia. John Sawyer published the study Man-Made Carbon Dioxide and the Greenhouse Effect in 1972. 37. He summarized the knowledge of the science at the time, the anthropogenic attribution of the carbon dioxide greenhouse gas, distribution and exponential rise, findings which still hold today. Additionally, he accurately predicted the rate of global warming for the period between 1972 and 2000. 38, 39, 40. The increase of 25% CO2 expected by the end of the century therefore corresponds to an increase of 0.6 degrees Celsius in the world temperature, an amount somewhat greater than the climatic variation of recent centuries. John Sawyer, 1972. The mainstream news media at the time exaggerated the warnings of the minority who expected imminent cooling. For example, in 1975, Newsweek magazine published a story that warned of ominous signs that the Earth's weather patterns have begun to change. 41. The article continued by stating that evidence of global cooling was so strong that meteorologists were having a hard time keeping up with it. 41. On the 23rd of October 2006, Newsweek issued an update stating that it had been spectacularly wrong about the near-term future. 42. In the first two reports for the Club of Rome in 1972-43, and 1974-44, the anthropogenic climate changes by CO2 increase as well as by waste heat were mentioned. About the latter, John Holdren wrote in a study 45, cited in the first report, that global thermal pollution is hardly our most immediate environmental threat. It could prove to be the most inexorable, however, if we are fortunate enough to evade all the rest. Simple global scale estimates 46, that recently have been actualized 47, and confirmed by more refined model calculations 48-49. Show noticeable contributions from waste heat to global warming after the year 2100, if its growth rates are not strongly reduced below the average 2% PA which occurred since 1973. Evidence for warming accumulated. By 1975, Manab and Weatherald developed a three-dimensional global climate model that gave a roughly accurate representation of the current climate. Doubling CO2 in the model's atmosphere gave a roughly 2 degrees Celsius rise in global temperature. 50. Several other kinds of computer models gave similar results. It was impossible to make a model that gave something resembling the actual climate and not have the temperature rise when the CO2 concentration was increased. In a separate development, an analysis of deep-sea cores published in 1976 by Nicholas Shackleton and colleagues showed that the dominating influence on ice age timing came from a 100,000-year Milankovitch orbital change. This was unexpected, since the change in sunlight in that cycle was slight. The result emphasized that the climate system is driven by feedbacks, and thus is strongly susceptible to small changes in conditions. 7. The 1979 World Climate Conference, 12–23 February, of the World Meteorological Organization concluded it appears plausible that an increased amount of carbon dioxide in the atmosphere can contribute to a gradual warming of the lower atmosphere, especially at higher latitudes. It is possible that some effects on a regional and global scale may be detectable before the end of this century and become significant before the middle of the next century. 51. In July 1979 the United States National Research Council published a report, 52, concluding, in part, when it is assumed that the CO2 content of the atmosphere is doubled and statistical thermal equilibrium is achieved, the more realistic of the modeling efforts predict a global surface warming of between 2 degrees Celsius and 3.5 degrees Celsius, with greater increases at high latitudes. We have tried but have been unable to find any overlooked or underestimated physical effects that could reduce the currently estimated global warmings due to a doubling of atmospheric CO2 to negligible proportions or reverse them altogether. Consensus begins to form, 1980 to 1988 main article, Attribution of Recent Climate Change, James Hansen during his 1988 testimony to Congress, which alerted the public to the dangers of global warming. By the early 1980s, the slight cooling trend from 1945 to 1975 had stopped. Aerosol pollution had decreased in many areas due to environmental legislation and changes in fuel use, and it became clear that the cooling effect from aerosols was not going to increase substantially while carbon dioxide levels were progressively increasing. Hansen et al. 1981, published the study Climate Impact of Increasing Atmospheric Carbon Dioxide, and noted, it is shown that the anthropogenic carbon dioxide warming should emerge from the noise level of natural climate variability by the end of the century, and there is a high probability of warming in the 1980s. Potential effects on climate in the 21st century include the creation of drought-prone regions in North America and Central Asia as part of a shifting of climatic zones, erosion of the West Antarctic ice sheet with a consequent worldwide rise in sea level, and opening of the fabled Northwest Passage. 53. In 1982, Greenland ice cores drilled by Hans Eschke, Willy Dansgaard, and collaborators revealed dramatic temperature oscillations in the space of a century in the distant past. 54. The most prominent of the changes in their record corresponded to the violent younger dryas climate oscillation seen in shifts in types of pollen in lake beds all over Europe. Evidently drastic climate changes were possible within a human lifetime. In 1973, British scientist James Lovelock speculated that chlorofluorocarbons, CFCs, could have a global warming effect. In 1975, V. Ramanathan found that a CFC molecule could be 10,000 times more effective in absorbing infrared radiation than a carbon dioxide molecule, making CFCs potentially important despite their very low concentrations in the atmosphere. While most early work on CFCs focused on their role in ozone depletion, by 1985 Ramanathan and others showed that CFCs together with methane and other trace gases could have nearly as important a climate effect as increases in CO2. In other words, global warming would arrive twice as fast as had been expected. 55. In 1985 a joint UNEP/WMO/XU conference on the assessment of the role of carbon dioxide and other greenhouse gases in climate variations and associated impacts concluded that greenhouse gases are expected to cause significant warming in the next century and that some warming is inevitable. 56. Meanwhile, ice cores drilled by a Franco-Soviet team at the Vostok station in Antarctica showed that CO2 and temperature had gone up and down together in wide swings through past ice ages. This confirmed the CO2 temperature relationship in a manner entirely independent of computer climate models, strongly reinforcing the emerging scientific consensus. The findings also pointed to powerful biological and geochemical feedbacks. 57. In June 1988, James E. Hansen made one of the first assessments that human-caused warming had already measurably affected global climate. 58. Shortly after, a World Conference on the Changing Atmosphere, Implications for Global Security gathered hundreds of scientists and others in Toronto. They concluded that the changes in the atmosphere due to human pollution represent a major threat to international security and are already having harmful consequences over many parts of the globe, and declared that by 2005 the world should push its emissions some 20% below the 1988 level. 59. The 1980s saw important breakthroughs with regard to global environmental challenges. For example, ozone depletion was mitigated by the Vienna Convention, 1985, and the Montreal Protocol, 1987. Acid rain was mainly regulated on the national and regional level. Modern period, 1988 to present IPCC assessment reports. First, 1990 1992 sup. Second, 1995 third, 2001 fourth, 2007 fifth, 2014 sixth, 2022 UNFC, WMO, UNEP main articles, Intergovernmental Panel on Climate Change, Scientific Opinion on Climate Change, and Global Warming, 2015, warmest global year on record, since 1880. Colors indicate temperature anomalies, NASA/NOAA, the 20th of January 2016. 60 In 1988 the WMO established the Intergovernmental Panel on Climate Change with the support of the UNEP. The IPCC continues its work through the present day, and issues a series of assessment reports and supplemental reports that describe the state of scientific understanding at the time each report is prepared. Scientific developments during this period are summarized about once every 5 to 6 years in the IPCC assessment reports which were published in 1990, First Assessment Report, 1995, Second Assessment Report, 2001, Third Assessment Report, 2007, Fourth Assessment Report, and 2013-2014, Fifth Assessment Report. 61. Global Temperature Trends 1880 to 2020, NASA, the 14th of December 2010. Since the 1990s, research on climate change has expanded and grown, linking many fields such as atmospheric sciences, numeric modeling, behavioral sciences, geology and economics. Articles on climate change science are now frequently published in major journals such as Science by the American Association for the Advancement of Science, 62, and Nature, 63. In addition, there are focused journals on climate change research such as Nature Climate Change, 64, Climate Change, 65, Journal of Climate, 66, Wiley Interdisciplinary Reviews, Climate Change, 67, and International Journal of Climate Change Strategies and Management, 68. Furthermore, many journals on related subjects continue to publish articles that build out the science behind climate change, for example Quaternary Research, 69. Discovery of other climate-changing factors. Methane. In 1859, John Tyndall determined that coal gas, a mix of methane and other gases, strongly absorbed infrared radiation. Methane was subsequently detected in the atmosphere in 1948, and in the 1980s scientists realized that human emissions were having a substantial impact. 55. Chlorofluorocarbon. In 1973, British scientist James Lovelock speculated that chlorofluorocarbons, CFCs, could have a global warming effect. In 1975, V. Ramanathan found that a CFC molecule could be 10,000 times more effective in absorbing infrared radiation than a carbon dioxide molecule, making CFCs potentially important despite their very low concentrations in the atmosphere. While most early work on CFCs focused on their role in ozone depletion, by 1985 scientists had concluded that CFCs together with methane and other trace gases could have nearly as important a climate effect as increases in CO2. 55.